Okay, now we're down to the last part for magnetism. Okay, now we're going to talk about the magnetic field. Okay, so magnetic field, what are they? Okay, so magnetic field is actually a region which magnetic object experiences a force. Okay, so how do we know the magnetic field? So example, when I got a bar magnet over here, the North Pole, the South Pole, what we can do is we can put a little compass. I put a compass here, and you'll see the needle pointing out. Okay, you'll see the needle pointing in this direction. Same thing, okay, maybe now we don't put it over in the middle, we can put it more to the side. You realize the needle point towards here. What we do is we can take another compass and we can plot the point. Okay, what I can do is, after we put the compass here, we take our pencil, put a little dot here and a little dot here. Then we remove the compass. Then we put the compass next to this dot again. You'll realize, oh, my compass looks like this, so I plot another dot. And realize by doing this repeatedly, you'll get dots formed in this order. Okay? And what you realize, you can actually connect all the dots. And connecting all the dots together, and the direction will be actually going in this way. This is a magnetic field line. Okay, so let's label this one is our magnetic field line. So take note, you can actually do this and the compass will actually point. So let's say if I have a compass, I put it here. Okay, it will actually point in this direction. If I have a compass over here, it will point in this direction. So a compass placed on a magnetic field line, it will actually follow the magnetic field lines. Okay, so this is actually using compasses. Okay, what we call this compass, we call it the plotting compass. Okay, we use a plotting compass. Now, so we know that the field lines, okay, a magnet have magnetic field lines. So for a single bar magnet, okay, how does the magnetic field lines look like? Okay, your North Pole will be going out, the South Pole will be coming in. Then what we're going to have is, you'll see loops like this. Same thing, at the bottom here, you'll see loops like this. Okay. Okay, all the lines going to the South Pole is all going in. Take note, so all those that is going to the South Pole is going in. All those that is coming out from the North Pole is coming out. So North Pole is the part where the field line comes out. Okay, where the South Pole is the one that's going in. So these are magnetic field lines for your single compass. Single magnet. Now what if we got two or more magnets? Example, then what if I got a bar magnet that looks like this? North, South. Okay, North, South. So north and north, you're going to have repulsion. So what you're going to have is, you're going to have lines that looks like this. Okay, the repulsion lines. Okay, the lines then still come to here. So north will still go to south, north will still go to south. Okay, north will still go to south. Sorry for the ugly drawing, but sorry for the wrong direction also. Okay, so magnetic field lines will look like this. Okay, coming out from the north, going into the south. And this means repulsion, where the magnetic field lines do not connect together. They seem like they want to avoid each other. So these field lines, okay, will actually tell you that this is a repulsion. Okay, repulsion. Okay, let me underline repulsion. Underline some more. Oh, sorry, can't see anything. Okay, repulsion. So take note, this is how you draw repulsion. Now, this is if North Pole, North Pole. How about if we try using two South Poles? If we have two South Poles facing each other, actually the magnetic field lines will look the same. We're going to have magnetic field lines that looks the same. Oh, sorry. Okay, magnetic field lines that looks the same. Okay, so what's the difference between these two? Okay, you can see all the field lines looking the same. What's different is the direction of the magnetic field lines. For north is coming out, so if there's a south pole here, it's actually all the lines are, the direction arrows is going into the south pole. Okay, going in towards the south pole, coming out from the north pole. So just take note of the direction arrows. Okay, now this is in terms of repulsion. How about attraction? So what if we got two magnets? Okay, and they attract. So north pole, south pole, south pole, north pole. So what we're gonna have is the lines will connect. Alright, let me use a different color. The lines will connect. Okay, the lines nearer to the corners, it will actually curve out. And then you're gonna have the normal field lines after that. Okay, so once again, north is going outwards into the south pole. North coming out into the south pole, coming out into the south pole, out into the south pole. So this in terms of your attraction. Okay, it's quite simple. So this is if they are close to each other. How about what if we are not having a head-on, we do a side-by-side? So what do I mean? Let me draw it out. What if the bar magnets are placed as such? North, south, south, north. So in this case, we know that there will be some sort of attraction. So how the magnetic field lines will look like? You're going to get lines that looks like this. Okay, nearer the corner, you're going to see it curve out. Okay, and this will go like this. Sorry. Okay, curving out here. Same thing. Okay, you're going to have it like this. This, and curving out. Okay, and this will curve out like this. Okay, north go towards the south, north go towards the south, north goes towards the south, north goes towards the south, north goes towards the south, into the south, out from the north, into the south, out from the north. So this attraction when your magnets are placed side by side. Okay, so this in terms of attraction when the magnets are placed side by side. How about repulsion? Okay, what if we're going to have a repulsion system? So let's draw it out. Okay, we're going to have two magnets here. North pole, North pole, South pole, South pole. So do you think the field lines will join? No, the field lines will not join. So they will tend to create a region where the field lines doesn't join at all. So how does it look like? So for this, how it will look like is that the magnetic field lines will not touch each other. And let me use a different color, sorry. This is red here. Okay, the magnetic field lines will not touch each other. They will do all their means to try to avoid each other. Okay, the rest will look as per normal. Okay. So they'll try to avoid each other. Okay, interestingly, this is how it looks like. So, same thing, once you've drawn the field lines, you show that the lines do not touch each other and they sort of show some sort of unwillingness to interact with each other. Okay, then you can start to draw off your direction arrows. Into the south, out from the north. Out from the north, out from the north, into the south. Okay, so this is how it will roughly look like. This is in terms of a repulsion when the magnets are placed side by side. Okay, so this is the end for the magnetic field lines. So you can see here, we talk about a single bar magnet, how the field lines look like. So this is for a single bar magnet. Right, sorry, single bar magnet. Okay, single bar magnet. Then we move on to talk about when the magnets are placed side, head on. Okay, repulsion. Move on to say it is a head-on attraction. And then this one we talk about side-by-side attraction, side-by-side repulsion. So this is generally the things about the magnetic field lines. Okay, just remember this. It's always put a star here. And it's always out from the north and then into the south. Okay, so that's all. Out from the north into the south.